In this video, we are going to explore how different arrangements of identical springs, each with the same spring constant, affect their extension when a force is applied. So let's take a look at 4 different specific setups. First, you are going to have 2 springs connecting series stretched by a force of 2 newtons. So in this spring we have 8 centimeters and the other one 8 centimeters, so total 16 centimeters stretch without the rings. The next arrangement, we have 3 springs in series and a force of 1 newton stretching the springs. So let me look here. Is we have 4, 4, and 4. 3 times 4, 12 centimeters stretch. In these next arrangements, we are going to set up 2 springs in parallel like this and place right here. And connected like this. So they are set up in parallel. I'm using this paper clip to help to hang the mess. Now everything is in place. I'm going to use the 6 newtons. 1, 2, 3, 4, 5, and 6. And let's look at how much it's going to stretch. Oops. So let's see, equally is this is 13 inches and this is also 13 inches. The last arrangement is with 3 springs in parallel. Let me give me a hard time here. There we go. 3 springs in parallel. 3 springs in parallel and 7 newtons. So I have 1, 2, 3, 4, 5, 6, 7. And I'm going to try to place right here. I'll be right back. Alright, so I'm using this paper clip and let's go. So it looks kind of in equilibrium and each one is stretching 10 centimeters. The question is, out of the 4 arrangements, which one will provide the largest extension? Now that I have provided the physical connections between springs in series and in parallel, we are going to answer this question from May-June 2011, paper 13, question 23. A number of identical springs, each having the same spring constant, are joined in 4 arrangements. A different load is applied to each arrangement. Which arrangement has the largest extension? To determine that extension for each arrangement, I'm using the same strategy that we use for resistors in series and in parallel. So in this case, if we are going to replace each spring with a resistor, so we have 2 resistors in series, 3 in series, 2 in parallel, and 3 in parallel. However, the formula is inverted. A and B, the springs are in series. So for springs in series, the inverse of the total spring constant, K total, is equal to the sum of the inverses of the individual spring constants. But we are looking for the extension, not the spring constant. To fix this situation, we need to remember that a spring constant is the result of a gradient between the force applied and the extension produced in the spring. So the spring constant is the force divided by the extension. Now I'm doing my substitution here. K here is F over delta X, and the total extension of these 2 springs here you'll be given by this relationship. And let's call this for the A, question A, multiple choice A, is equal to K over 2. Now I'm going to rearrange this for my delta X, doing cross multiplication. So it'll be 2 times my F is 2 over K. So my extension for the arrangement A is 4 over K. Now for arrangement B, so we have 3, so we add the inverse, which means that 1 over KT is 3 over K. 1 plus 2 plus 1 plus 1 plus 1, 3. All right, so now I'm going to flip it both, just like I did on option A. So my KT is K over 3. Likewise, I'm going to do my substitution. K is F over the extension for arrangement B is K over 3. Because we don't know the value of K, we know they are all the same. So the extension for B is, doing cross multiplication here, the F is 1. So 1 times 3 is 3. Let me write how I did. 1 Newton times 3, right? 1 times 3 over K. So for the arrangement B, we have a 3 over K. For arrangement C and D will be easier. So KT is the sum of the individual spring constant. So it will be K plus K. See, the opposite of resistors. In resistors, it will be the inverse. It will be the sum of the inverses. So this is KT is 2K. And then we do the same thing that we were doing before. So my K is the total force applied over the total extension for C is equal to K. So I'm looking for my extension for C is cross multiplication again. Will be my F, in this case is 6 over 2K. So this is 3 over K. So look like that we have 2 with the same extension. The last arrangement, D, is KT is K plus K plus K. So my KT is 3K and my KT is the force over, let's call extension for D is equal 3K. So again, I'm looking for the extension for the arrangement of option D, which is F, in this case is 8, right? So it will be 8 over 3K. So the last step, we are going to compare the results of each extension. So here I have 4, 3, these two here are equal, and 8 over 3 is 2.6. So the largest extension will be option A. So option A, you have the largest extension.